Hi folks, so in this video what we're going to be doing is completing two questions here based on the topic of solids and contacts. Question 1 here and then question number 2 here. And these questions here primarily kind of revolve around using a revolve kind of method to actually complete them, okay, or a rotation method, not a revolve, but a rotation method to actually complete the questions. So you can see here we have an upright cone standing or sitting on its base, and then we have a sphere in contact with it. And this one we have an inverted cone, once again with a sphere in contact with it. Okay, you can see here we're given the elevation and the plan views of both, and they give us the information required to complete the questions then, and once again over here as well. What we're going to do is we're going to complete this one here on the right first, and then using the same principles apply it to the one here on the left as well. Okay, so if I just refer out to my drawing here, you can see here I have two XY lines set up, and I have a printed out sheet. So the first question we're going to do is we're going to complete this one here, and then we're going to do this one. So as always with all the questions, various cones and spheres are in contact with each other on the horizontal plane in each of the two orthographic projections below. In each case, draw the given views and locate the points of contact. Okay, so you can see here we're given a cone. If I just zoom in there a little bit. So looking at this one, okay, we have to look at the information they give us about the cone. So we know when we look at a cone in elevation view, we see it as a triangle. We can see the triangle there. The altitude of the cone, which is the height, is 80 millimeters. And then we need to actually learn what is, or try and find what is the overall, I suppose, dimension or the length from here to here. Now, it doesn't tell us in the elevation, but in the plan view, if you look at the cone, we see it as a circle. That would be the apex, which is up here in elevation, which is where it is here in the plan. And we can see that they tell us the diameter is 64. That means that the distance from there to there is 64, or from the middle, it would be 32 to the right and 32 to the left. And then we would also draw it in the plan view. So that's where we're going to start with, and I'll refer back here in a second. So, using our set square here, we're going to do a cone up here at a height of 80 millimeters. So do a vertical line, and on that line I'm going to measure 80 millimeters. So from 8 up to 16, so that's 80 millimeters. And then from the apex there, I'm going to measure 32 millimeters to the left, and then 32 millimeters to the right, and then connect those up. So from the apex, connect that one to there, this one to here. Okay, we've drawn our cone there. Now in the elevation view, I'm actually just going to zoom in on that one there. Let's move this ever so slightly, just so we can see it in a little bit more detail. Now, the center point of the cone, which we'll see in the plan, will be directly below the apex. And then it does not matter where I set up, I suppose, my axis line running across. Just don't set it up too close, because we have to draw in a circle that's going to fit in with a diameter of 32. Sorry, a diameter of 64, a radius of 32. So we'll do the line about there going across. And then to actually get the radius from here, just do a straight line down. Now using my compass, from there to there, I'm going to draw in my cone. And as you can see, it lines up. Okay, so there's the cone in both elevation and plan. Now what we have to do is we have to get a sphere. Having found that, we have to get a sphere that is in contact with the cone, and you can see it's kind of overlapping here. So it's not technically touching our extreme generator, which is this guy here. Okay, we've just got the sphere and it's slightly overlapping, and you can see from the plan view here, it's actually center point is 45 degrees from the center of the cone. Okay, so you can see it goes down 45 degrees. The other bit of information they give us is the diameter of 50. So if the diameter is 50, then the radius is 25. So that's the first bit of information. Now, what I'm actually going to do is we're going to have to actually draw what's called a ghost sphere in here, and then we're going to rotate it into its correct position. Okay, and the ghost sphere is going to be in contact with the extreme generator. So the method is, if the radius is 25, then the center point of that sphere has to be 25 millimeters above the XY line. So we're going to put in a line going 25 millimeters above it. So that's the next stage we're going to do. So from the XY line, I'm going to do from the 7 here, I'm going to measure up 25 millimeters, 10, 20, sure it's right there, 10, 20, 5. Now I know I have a sphere, and somewhere along that line is going to be the center point of the sphere. Okay, the problem we have is we cannot determine the exact position just yet. So what we're going to do is we're going to put in a ghost sphere when it's touching the extreme generator, if we imagine it at the exact left-hand side of our object. So the line that's created between the extreme generator, or the angle that's created between the extreme generator and the XY line, I'm going to bisect that angle. So compass point there, swing an arc, swing an arc. Then I'll change this slightly, swing an arc, come back down here and swing an arc. Now, what I'm going to do there is I'm going to connect this point down to here. And what's helpful is where that point cuts through my 25mm line that I measured up, gives me the center point of a sphere. Actually put it in a different color here now. Go to green. This is a ghost sphere. We radius 25, just want to make sure you're happy with that. So this is what I'm going to call a ghost sphere. Okay, after putting it in green there. Now the purpose of the ghost sphere is it gives us a sphere that is the size that we want, but not in the correct position just yet. But it also helps us determine a center point. So I've now got that center point there. I want to find it as it's touching the extreme generator of our cone. So by extending out this guy down to here, I can then redraw my ghost sphere in. So once again, taking the radius from here to there, I'm going to redraw that in. There, like that. That's my ghost sphere, once again, when it's in this position. Now we know we need the center point at an angle of 45 degrees coming from the apex of the cone. Now the only method we're actually going to do here, or the only step we're going to follow here now, is we're going to rotate the center of the ghost sphere until it's in its correct position. Because as that sphere moves along and moves around the cone, the center point will always be the same distance away from the center of the cone. So if I get that point here and rotate it around, I have now found the position of the sphere when it's in its correct position. Okay, let's move that slightly there. Now what I'm going to do, now that I've found that, I can now draw in that sphere fully. So I'll take the radius which I had from up here, so I'll mark it out there, checking that, using the same center point then, or the new center point I found, I'll draw in my sphere. So I've now drawn the sphere in my plan view. I'll now heavy in my cone. And there we go, heavy in the cone. And the last bit I'm going to heavy in then is the hidden detail. Because the sphere is overlapping the base of the cone. Okay, so I've drawn that in my plan view. I also have to now draw it in my elevation. So now that I've found that, let's move that ever so slightly there so it's on the screen. Now that I've found the center point of where the sphere is in its correct position, I can redraw it up in elevation. Bring the center point up, and the sphere then just moves from here to here. So once again, getting your compass, using the same radius. So take my radius from here, using my correct center point now. Once again, it's overlapping it. Draw that in and heavy in my cone. So there we have it. We have now completed the problem whereby we're after drawing both the elevation and plan view of our sphere in contact with our cone. And once again, essentially we found the center point in the correct position. Okay, so what we used was a GO sphere. We brought it down here in the plan view and we rotated the center around. Now the last part of any soils and contact question is you have to determine your points of contact. The only way we can find a point of contact between the cone and the sphere is when we see it in the GO sphere position first of all. So normal rule is you go perpendicular to the extreme generator from the center of the sphere. And in this case we have to use the center of the GO sphere. So perpendicular to the extreme generator from the center of the ghost sphere. So there we go. I've now found that point of contact when it was in the GO circle position. So likewise, we're going to project that down to find that point of contact when it was in the GO sphere position. And once again, we're going to rotate that around. So get it here and rotate it around until it's in its correct position. Right there now is our point of contact located with the letters P, O, C. Now that I've found them in the plan, project it up, and the point of contact will stay at the same height and elevation, so just bring it across here. That's the one I'm going to locate as P or C. Okay, so there you have it. There is the first question completed, guys. Okay, and what we're going to do now is we're going to apply the same rules to the next question, only difference is we have an inverted cone. So that's the first problem done there, and you can see there's quite a bit of complex geometry involved in it. Now what we're going to do is we're going to complete this question here. So once again, we're going to look at the information given. First of all, the altitude of the cone, okay, is 80 once again. And then they actually don't tell us the diameter like they did in this one, was diameter 64. They don't tell us the diameter here, but what they do tell us is that these lines here are at an angle of 60 degrees and 60 degrees. So that's the first thing I want to do, draw the elevation and plan of the cone. So on the left hand side, I'm going to start off with a line. I'm going to measure up as far as 80 millimeters and do a line to the left and right like this, and then go 60 degrees like this and this. So there is our cone in elevation. We now have to find the cone in plan. Likewise with the center of the circle in plan, as we would see it, right down, line out like this. Top point, bring this down as well, should work. And now draw in my circle, because that's what the sphere, or sorry, not the sphere, the cone is going to look like in the plan view. In this case, we're seeing the base of it as it has been inverted. So there it is. Okay, that's the first part of the question. Now we have to look at the information supplied to us. So you can see here we've got a sphere in this position here. If I just zoom in there so slightly, it has a diameter of 48. So once again, like the last question, this one, last one we had a radius of 25. This one we have a radius of 24. And then in the plan view, you can see from the center of the cone to the center of the sphere, it's at an angle of 60 degrees. And you can see that the center of the sphere is actually inside the circumference of the cone as we see it in the plan view. Okay, so it's 60 degrees. So first of all, the center point here for the sphere, it has to be up 24 from the ground. And the only difference is, once again, we're going to use the same principle where we get a GO sphere. The only difference is we're going to be bisecting an acute angle rather than an obtuse angle that we had over here. We're going to be bisecting an acute angle. Okay, so that's what we're going to do. So using the radius of 24, okay, very similar to the last question, we're going to measure up 24 millimeters. So in this case from 10 up to 12.4, that's my 24. And then using that radius, I'm going to then bisect the angle. From there to there. Having bisected that, just won't connect it the whole way. It helps me determine the center point. Once again, I'm going to put this in green, of a ghost sphere of radius 24 that is in contact with the XY line and the extreme generator of our cone. Now that I've found the center point of that ghost sphere, I'm going to now draw it in the plan view as well. So bring the center point down. In this case, this is my new center point. Because the cone has been inverted, they're overlapping. Once again, make sure I have the right measurement here. I'm going to draw that in its position there. And the next thing we have to do is we have to determine where the exact center point is, and we know it's at an angle of 60 degrees. So I'm going to use my set square here from the center point of the cone. I'm going to go 60 degrees down like this, and then it's simply a case of rotating the center point when it was on the extreme generator around. And I've now found the exact center point that I want. Now that I've found the exact center point, I'm going to heavy it in the right information. So first things first, I'm actually going to heavy in the cone completely. Yeah. And then using the same radius as I had up here, there we go, come down to the new center, and I'll heavy in the outside portion, and then hidden detail, because the sphere would not be visible underneath, as the cone in this case is the one overlapping it. Okay, so there we have that. Now that we've found that, I'm going to do the exact same thing and find it in elevation. So now that I've found the center point, I can project the center point up, and the center point comes across, and I can find the exact position of it right here. And in this case, our sphere is going to overlap the cone because it's slightly at the front of it. So once again, let's take my measurement from here. There's the center point, and in this case, I can fully heavy it in. Okay, now that I've found that, I'm also going to heavy in my cone. So heavy this line, this one, and this one, with hidden detail inside there. Okay, so you can see the difference in the two questions. Okay, the only difference was that we had an inverted cone over here and we had an upright solid here. Okay, standing obviously with the base of the cone on the ground. In this case, the apex was obviously flipped over. Now the last part of this question, once again, like the last one, we have to find the point of contact. Same principle is going to apply here. We have to go perpendicular to the extreme generator from the center of the sphere. So, using our two set squares, multiple ways you can do this. You could put the number side there like that, slide it along, rotate it. It's just my visualizers in the way up here. The way I'm going to do it is I'm going to put the long edge of the 45-degree set square on the extreme generator, like that, and then flip it around, and from the center of the ghost sphere, so let's use that one first, that'll help me find the point of contact when I was using the ghost sphere. Now that I find that, I bring it down. You can see here, it seems to be in line with this one. That's where it is when it's projected down. And then simply to find it, the exact position, I also, like we rotated the center, I have to rotate around the point of contact. And that there is my POC in plan. If I found it in plan, I have to find it in elevation. So an elevation, it will be at the same height, so project it up, and project this across POC. Okay, so there you have it, folks. Just zoom out there slightly. As you can see, we're after completing these two questions, whereby we used the principle of using a ghost sphere on the extreme generator to complete both of them. The only difference in the questions was obviously the radiuses and so forth, but it was the same principles. The only difference was we had an upright cone here and we had an inverted cone here. Okay, that's the two questions completed there, guys. I hope you found those helpful.